Welcome back to my channel, guys. Mm. My name is Novendobi. I'm a software engineer with about 7 years of professional experience. I realized recently that I've been like an introverted engineer that has been building very scalable applications, working, and somehow I don't know how time passed. I just realized today, I found out that, oh, it's been 7 years already since I started writing code, understanding system design, getting conversant with modern technologies, and basically building stuff. So I just decided that, oh, I'm going to be sharing my knowledge with people. Let me try and maybe put myself out there, put what I've learned over the years out there. And since I just started my own company, or my own startup, I decided that, oh, okay, I think it's time for me to level up. 7 years is not a joke. I should also give people like a bit of what I understand and how I break it down to myself. So let's begin. Our topic for today is context-free grammar. I'm going to be breaking it down. Most people wonder. They always how do computers actually understand what we ask them to do? How does a simple command like print hello world know that you should display text on a terminal? How does it know that if I type print greater, it prints out greater for me? If I type print lesser, it prints out lesser for me. How does this communication happen? How does it even make sense to the computer? Why is this syntax valid in one programming language and invalid in another one? In fact, why are there so many languages? Why do we have Python, Node.js, Rust, C, C++? I can go on and on. Elixir, Raspberry, Rascal metaprogramming language, and the likes. Why are there so many languages? If I ask you that, what is a compiler really doing? Questions like what's a compiler doing? And how do people even build one? So I think the goal for today is to demystify all those questions, and eventually even help us build our own basic compiler. We're going to be doing all that today. So this is some high-level shit, some high-level stuff. Yeah, let's go. So all of this starts with context-free grammar. What is context-free grammar? I'll just say that context-free grammar is a contract between human beings and machines. It defines what is allowed to be said. Not what it means yet, just what is allowed to be said. We have the grammar, abstract tree, and then the semantics, the logic. We are not going into the semantics yet. We're not going into would we touch the abstract tree? I'm not sure. I'll just hit on context-free grammar before we go in depth. So, like I said, it's just basically a contract between human beings and machines. That's telling the machines what is allowed to be said. It defines what is allowed to be said in this context. So, let's say if you're still confused about what I'm saying, you can ask yourself, what does this person mean by defining contract of what's allowed to be said? I'll use simple human grammar, because a context-free grammar is like the contract that's telling the machine that, okay, this is what is allowed to be said. But in that same sense, what does it mean? It means that we are trying to set up a standard of conversation with the machine, a means of conversation. For instance, I say, come. I tell a human being, come. I have passed in, is it waves or whatever? I can't really explain that, but I've given an instruction that you should take your foot and make that movement and come to me. You process it. You understand what I say. We've communicated. But now, this is the same thing we are trying to do in the machine. But the only thing is that human beings are already intelligent. They already have this basically naturally encoded. But the machines, how do they even know this? How do they even know? Because they are empty. That is where context-free grammar comes in. A context-free grammar, like I said, is a contract between humans and machines, defining what's allowed to be said. So, in human terms, you can just see it like a grammatical structure. For example, you say, he are here. Let's say you wanted to say he is here. If I asked, oh, where is November? And somebody says, he is here. Imagine I ask, where is November? And somebody says, he are here. The first thing that comes to your mind is, if you understand English properly, you'll be like, oh, grammatical blunder. You're going to catch that. But maybe because you have higher intelligence, or up to, or more than up to the level of artificial intelligence, because most probably things like AI is going to mimic human intelligence. So if I say he are here, you know that okay, the person is trying to say he is here, but don't forget that your brain calls that is an error. You just probably inferred on what the person was trying to say. Does not mean that he are here is correct. It's grammatically incorrect. We just infer the meaning, but for computers, they have to be precise in order to know what action to carry on. So, the early stage computer is not artificial intelligence, basically. And, like we said, in terms of actual computer communication, it has to be deterministic. So I'm not talking of, because some people confuse AI with, when I say early stage computers, that I don't know how to explain it, but computers, the main computer has to be deterministic. You cannot say he are here and it says, oh, that's grammatically correct. No. Instead, even AI has to basically infer that, oh, he's trying to say he is here, which is grammatically correct. But he are here is incorrect, and that's a fact. So, that structure basically here explains, okay, this is how we communicate in English. How does a computer communicate? English has structural rules that says a sentence is made up of a subject and a verb, and the verb must agree with the subject. So structure, so like in structure, English expects something like a sentence that should be a subject, a verb, and location. Like it should have, okay, let me not go into the context of grammar yet, but it says that for this to be a sentence, it should have a subject, a verb, and a location. Right? So, what is a subject? A subject is like a pronoun. It can be singular or plural. Like, I'm not going deep into English. I'm just like in terms of the structure. Now, what's the verb? The verb form that matches like the subject. So now, where we want to apply like the structure, he is one person, singular, right? A singular subject. Is plural. In that case, you see that the structure will break because we have violated the definition of what is allowed. Basically, it does not match, so it is invalid. So this same idea is the same idea behind like a context-free grammar. It defines structures that are allowed. It says which structures are allowed before we even talk about meaning. How can you say here? Like maybe when you want to infer meaning, you can now say, oh, this is what person meant. But structurally, in our definition, in our contract, you broke the structure. So human beings in the past, they needed a way to talk to machines. How were we talking to machines before? Not even before, to date. It was through binary. But binary was difficult. Imagine writing things in ones and zeros. On and off. 1, on, 0, off. It worked, but it was painful. Imagine writing print hello world as binary. The ones and zeros. Even if you could, like, one mistake is going to like break your code, and you are going to be looking for where is this coming from, because you can't even tell. Just print hello world. I even wonder how they actually wrote code there. Probably have to do more research. So basically human beings had to like build layers like this. Basic method of writing is binary, right? Of communicating with the computer is binary. They went on to assembly. Then higher level languages like C, Rust, eventually Python, Node.js, and the likes. But when you look at that, you still see that there are layers on layers on layers. I cannot ascertain for sure, but I think yes. So layers upon layers upon layers. So, but here's the actual deal. When you say invent a programming language, which is a way that a way that you want a person to be able to talk to the computer, to be able to automate things, you have to say what counts as a valid sentence in this language, because a computer needs a reliable structure to interpret. Don't forget that the basic, eventually everything runs as binary. Let's say C was created, properly defined too. Properly defined, and everything maps down and compiles correctly to its bits that eventually runs on the computer. And you say, oh, C is too high level. I need something more human readable. I need to solve the problem of race conditions. I need to solve the problem of, okay, what if somebody does not really understand computer memory allocations and does not want direct manipulation of memory, does not want, okay, cleaning of memory after values are no more used on the memory. You know that variables and everything are actually stored on temporary memory. So like, if for instance we did not have things like garbage collector in Python, those we are going to have lingering values up and down. So let's say why Python wanted to solve that issue of lingering values, unlike the way other programming languages solve it. They feel like, okay, this is going to be more easy, this is going to abstract a whole lot of things and just allow people to write clean code. You have to ask yourself, there should be a structure that the computer will see and say, okay, now I'll carry out all the instructions that I was asked to do. There has to be an understanding that com is com, print means put out to the terminal, return means pass value through, def means that any variable after that is a function. You have to basically specify all this. Yeah. So context-free grammar is basically the grammar of a programming language. It defines what is allowed to be written, how the code can be structured, nested blocks, functions, expressions, just like I've explained. Meaning is later on to know, okay, this is what a function means or whatever. But you have to say this is a function. We don't say what a function does yet, but we have to be able to say this is a function. So context-free grammar makes it possible for the compiler to even say, yes, this is valid code. You can make a meaning out of it. If not, they cannot communicate. They're speaking gibberish. Like, I cannot even process it. It can't even go in. So that's the bridge from human-friendly code to machine instructions. Machine instructions that would have been a hell of life or whatever. So if writing code does not make it easy for human beings, development won't be as fast as it is today. Who knows, even maybe after 7 years, who knows what I would have built by now. I might not even have had one successful product shipped, or not to talk of any other thing. Just imagine the amount of workforce that is needed to build something that will be needed to build something as simple as a calculator app, like just a basic calculator app. And even after building it, who maintain it? Let's say, okay, the main people that knew about the code base starts getting old. I think that was even part of the problems that made software developments, that made people start looking for alternatives in building better programming languages, compilers, transpilers, and stuff like that. Because who would have maintained all those stuff they built? They had to be a system on top of it for generations to come. So basically, the world we see today is because coding has been made human friendly. In many cases, it's also some cases or many cases, it's almost like English. That's why there is rapid developments, different softwares to make your life easier, computers, operating systems, chips, boards, AI, robotics, and many more, because programming was made easy. If not, you would even write and most of these things will not scale. So languages like Python, they deliberately simplify things, reducing complexity and hiding low-level details so humans can focus on intents rather than mechanics. Because if everybody needed to be a professional to do most of these things, where would they have gotten to? I know you need to be a professional still, but not at a very basic level. Like, if somebody has already invented the wheels, why reinvent it just to feel smart? Just carry no. If it has been invented already, I think we should go further and invent more things. So this was the problem that had to be solved. But then it did not happen by accident or anything. From assembly down to C++, Python, they are all introduced to define how code should be written and structured. Many of these languages are built on top of earlier ones, forming layers of abstraction. No matter how high level a language becomes, it eventually has to be translated back down through compilers or transpiler into binary, because even if it's transpiled languages, at the end of the day, let's say transpiled back into a high level one, the high level one eventually runs as binary. So no matter how that most of the languages, Python was written probably on top of C, transpiles back using its transpiler, even this C eventually runs as binary. So no matter how high level language is, that's what translated back down into binary. And binary is the only language that a computer understands. So this is where we then talk about our context-free grammar properly. Through structure, you see that we define a contract. We say how our thoughts are written as code. We say this is our thoughts. We would want to define something that says whenever you say add 1 plus 2, you have given it 1. Ensure that you gave it, whenever you say add, ensure you give it 1 and ensure you give it 2. If you ensure you gave it 1 and ensure you gave it 2, we then say, okay, return 1 plus 2. Like we tell a computer add, it knows that it just returns 1 plus 2, 3. You just so once you tell it add, it returns 3. Like how do we get to that part? That's why we define a contract. We define a contract, so we want that a function, the first thing that we want, the first structure we want to get is the structure of a function, which is which could be any instruction basically. So then we now say, okay, how is this code going to be organized? Can maybe a function have a variable inside it? Can a function have a class inside it? Is that acceptable? What are we trying to achieve? How do we go about that? So you have to define, depending on your goal and problem you want to solve, you have to say, okay, define the contract between you and your computer, your machine, and how that can be safely translated step by step down to memory and execution. Because if you say add 1 plus 1, like eventually that should be run as binary for you to know that, okay, you're talking about expressions, valid expressions, 1 plus or whatever. And obviously there is its own representation in the high level language and binary basically, or even the ones that go down to assembly first. So basically, like I said, without deep learning curve, you see that people are able to interact with their computer. Now, to solve this, to deepen our understanding, let's look at maybe a very small grammar rule. Let me open one for you. Yeah, let me open one for you. Let's say we want a language that can do one thing, that can just print hello world. No, the hello world or hello or whatever. In our thoughts, we know that we plan to achieve, we know that what we plan to achieve is sending our computer on an errand like, see, computer, come here, take your blackboard, write out whatever you see in between quotes. So you have to tell it what a computer is deterministic, so you cannot even assume anything. Say, okay, just go. Anything you see in between quotes. No, you have to tell it that, okay, this is the structure we want. We want something that can print hello world, right? We have to actually tell it what is grammatically correct. We have to pass it. We have to go through the structure. So before a computer can run this, it must first answer, is this even written correctly? If it answers that and says, oh, this is written correctly, it can then proceed to the next step. So let's define a context-free grammar of the print statement. So a statement in this aspect now is going to be called print. So this is statement. A statement can be a print statement. A print statement. Okay, let's not give it extra terminals and non-terminals. I'll go into those concepts of terminals and non-terminals. But before then, let's say we want to. Let's say we define. We say a statement should be print. We define print inside parentheses, then a lexical string. Let's call it text. Text is the lexical string literal. So string literal is basically anything in quotes, which is a lexical, a lex or whatever it's called. Lexical. So this rule is simply saying a statement must start with print, followed by an opening bracket, then followed by some text and the closing brackets. The text basically in this sense is anything in between quotes. That's what I define this string literal as. Now look at this. Let's say we write print hello, valid, because that is the grammar defined. We say print hello, no quotes, is invalid. We say print hello, no closing parenthesis, is invalid. And if you are used to programming, I think many of us here are, you are going to see that when you write something, it's either if it's statically typed, it will tell you you have a red there. Even writing that is dynamically typed, you still have a red there. And when you try to run it, it fails. It fails. So yes, it fails. So all this is not because maybe the computer hates you or something. It's just because you don't match the structure of what you just wrote. So this is what a context-free grammar rule is doing. Not executing anything, it's not printing anything, it's just checking structure. If the structure matches, the computer say, okay, I understand this. Only after that does mean execution come in. That's the smallest sum of the contract.